Imagine cutting the price of every model call by 80% and still doubling the cost of getting the work done. If retries, tools, reviews, and failed actions rise, cheaper tokens do not create cheaper outcomes. That is a tokenomic problem. This briefing asks a more useful question. How much approved, productive work do we get from each unit of computing? We will examine the enterprise AI agent companies and products shaping the market, how regional conditions differ, where applications are most ready, and how leaders can improve outcomes per compute dollar. Let's begin with the strategic shift behind the framework. The first shift is from measuring software by seats or activity to measuring approved, completed outcomes. That changes the executive question from how much AI are we using to what valuable work is being completed, at what quality, risk, latency, and total cost. The adoption signals on the right show strong interest, while the cancellation forecast is a reminder that enthusiasm is not the same as production discipline. The implication is that workflow context, governance, and outcome measurement are now part of the economic model. Next, we will define that model more precisely. Tokens tell us how much model work occurred. They do not tell us whether the enterprise gained value. The tokenomic North Star puts outcome value and success in the numerator and all completion costs in the denominator. Those costs extend beyond model inference to tools, infrastructure, oversight, and rework. Notice that a run may include input and output tokens, cached context, external tool calls, and non-model operating costs. The practical KPI is total cost per approved completed outcome. With that equation in mind, let's see why an agent can consume much more compute than a single chat response. An agent is a governed loop, not simply a chatbot. It observes the request and current state, plans the work, acts through tools or other agents, verifies evidence and policy, and either escalates or retries. Each loop can raise the probability of completion, but it can also multiply compute, latency, and risk. The main multipliers are duplicated context, repeated reasoning, tool calls, handoffs, and evaluation. The design principle is to separate reasoning authority from action authority and spend additional compute only where expected value or risk reduction justifies it. This loop sits inside a broader market stack, which is our next topic. The enterprise agent market is not one clean category or one TAM. It is an overlapping stack that runs from infrastructure and models through context, orchestration, and the user experience. Vendors expand vertically because strategic control comes from combining distribution with trusted enterprise context and authority. Durable power tends to concentrate in 4 places: where work happens, where proprietary data and process state live, where permissions are enforced, and where runtime economics can be optimized. That is why we should compare complete control planes rather than isolated assistance. The next slide maps the vendor archetypes competing for those positions. This landscape groups vendors by the advantage they bring rather than ranking them. Hyperscalers combine distribution, plow controls, and model choice. Application suites bring process context from CRM, IT service, ERP, and HR systems. Data platforms provide governed information and evaluation. Automation platforms connect agents to deterministic execution and legacy applications. Model providers compete on reasoning and developer ecosystems, while infrastructure and regional providers emphasize runtime, governance, language, or sovereignty. The selection rule is straightforward. Choose the platform that can reach the right context and tools under the right policy at an acceptable outcome cost. Geography then changes how that choice is made. The global market develops differently by region. North America is strongly influenced by cloud suites and developer platforms, with ROI and security as major filters. Europe places more weight on sovereignty, auditability, labor considerations, and regulatory obligations. China is shaped by domestic cloud and model ecosystems, as well as cross-border data constraints. The rest of Asia Pacific is highly diverse in language, industry, and legacy systems. The Middle East combines national AI programs with sovereign compute and localization priorities. A useful global default is portable architecture with local data, controls, language, and policy evaluation. Now let's move from markets to the applications that are most likely to work first. The strongest early applications are bounded, frequent, and measurable. Customer and employee service are attractive because requests can be classified, evidence can be retrieved, and exceptions can be escalated. Sales, finance, engineering, and operations also offer value, but each carries a different control burden. Readiness rises when the action space is constrained, the completion signal is visible, and human review is inexpensive. Avoid beginning with open-ended, high-stakes decisions where data lineage or authority is unclear. Once a suitable workflow is chosen, 6 operating levers determine whether its economics improve. Improving tokenomic return requires optimizing the whole system, not simply finding the cheapest model. On the cost side, route each task to the smallest capable model, retrieve only relevant context, and reuse stable prompts and verified intermediate results. On the completion side, make tools reliable, place human gates at irreversible or high-value actions, and evaluate every run. A cheaper call that causes more retries or review can create a more expensive outcome. The operating rule at the bottom captures the principle: spend more compute only when it raises expected outcome value or meaningfully reduces risk. The next slide translates this into a phased executive agenda. Treat the first year as building an operating model, not accumulating demos. In the first 90 days, prove a small number of bounded workflows and establish a human baseline for cost, quality, and cycle time. Over the next 3 to 6 months, standardize identity, tool permissions, data paths, evaluation, and incident response. By 6 to 12 months, scale a portfolio by reusing tools, policies, and workflow components, and retire agents that remain high in rework or low in value. The executive watch list is outcome, cost, escalation, incidents, portability, and compliance drift. The following section goes deeper into the implementation choices behind this roadmap. This section turns the strategy into an operating system. We will examine where industry value appears first, what drives workload intensity, how to measure full outcome economics, how to separate reasoning from authority in production, and which capabilities to buy, build, or source through partners. The goal is to connect the tokenomic thesis to concrete architecture and portfolio decisions. Industry value usually begins in a narrow workflow wedge rather than a broad autonomous role. In financial services, that might be collecting KYC evidence and routing exceptions. In healthcare, it could be preparing prior authorization evidence. Manufacturing may begin with maintenance triage, retail with catalog or service resolution, the public sector with case intake, and utilities with incident diagnosis. Each wedge needs a value measure and a non-negotiable control. The portfolio rule is to scale only when there is a named owner, observable completion, a clear authority boundary, and a defensible cost baseline. Those economics depend heavily on workload design. Compute intensity increases as a workflow moves from simple retrieval and drafting toward analysis, action, and multi-agent coordination. The main drivers are not prompt length alone. They include how much context is copied, the number of planning steps, tool and search calls, retries, evidence requirements, and approval effort. This is a categorical continuum, not a pricing benchmark. Instrument these multipliers so the team can see why a completed outcome is becoming more expensive. Then reserve the most costly reasoning patterns for decisions whose value or risk truly warrants them. The next slide shows how to account for the full cost. The visible model bill is only one part of the cost to complete an outcome. The denominator should include model inference, tools and data access, runtime, control activities, and failure costs such as retries, rework, or abandonment. The numerator should reflect the value of outcomes that actually meet the approval standard. Use the same outcome definition when comparing the human baseline, the pilot, and skilled deployment. That prevents teams from claiming efficiency by excluding review or correcting work. The board-level measure is value delivered per approved completed outcome. To protect that value, the production architecture must make authority explicit. A model may reason, but it should not automatically inherit permission to act. This reference architecture separates the experience layer from orchestration, the authority boundary, execution systems, and the evidence layer. Before any material action, the control plane should answer 5 questions. Who is acting? What may be accessed? What may be changed? What evidence is required? And when a human must release the action. These references play different roles. NIST is voluntary guidance. ISO 42001 is a management system standard. And the EUAI Act is phased regulation whose high-risk obligations now begin in December 2027 rather than August 2026, with transparency duties starting this month. This separation makes accountability and auditability part of the design rather than an afterthought. In short, the agent proposes, the control plane authorizes, and the system records evidence. The final implementation choice is what to buy, build, or partner for. The durable advantage is rarely the generic agent shell. Buy commodity capability such as foundation model access, standard connectors, baseline monitoring, and elastic infrastructure. Build the elements that encode enterprise advantage, domain semantics, proprietary tools and policies, evaluation data, and workflow-specific experiences. Use partners where legacy integration, regulated deployment, or organizational change requires specialist capacity. The recommended default is a portable platform with enterprise ownership of context and evaluation, reserving custom engineering for workflows that genuinely differentiate the business. Let's close by consolidating the executive decisions. 5 decisions define the tokenomic operating model. First, choose a completed business outcome rather than an AI activity metric. Second, define what the agent may read, recommend, change, and release. Third, instrument every run so total cost and failure are visible. Fourth, source for leverage by buying common capability while owning differentiating context and evaluation. Fifth, scale only when measured value improves after controls and rework are included. The principle is concise. Maximize approved outcomes per unit of computing without exceeding the enterprise's risk appetite. I'll finish with how to stay connected to future updates. Thank you for joining this tokenomic briefing from Introcorp by S. We publish a new update each week on enterprise AI agents, computing economics, and the changing market landscape. If this analysis was useful, please subscribe for the next briefing. Give it a thumbs up so we know what resonates, and leave a comment with the company, application, or market you would like us to examine next. Your feedback will shape the next edition.